Alright, in this problem we've got a 4 by 4 square grid and we're asked to figure out how many squares of any size do not contain the mouse. Alright, so here's the mouse and he's sitting in this square which is 2 down and 2 over from this top corner. And now it says squares of any size. So you can see there's obviously 16 of these small squares, right? 1, 2, 3, 4 by 4 is 16. But when they say any size, they also are talking about these 2 by 2 squares, like this, or 3 by 3 squares, or even the 4 by 4 squares. So you can see there's a whole bunch of, there's a lot more of these 2 by 2 squares. I can find one here, I can find one here, and so on. That's the first thing to clarify, is that is what they mean by squares of any size. Okay, now when I look at this, to me it seems like it's easier to count the squares that do contain the mouse. The ones that don't contain the mouse, to me seem like they are a little harder to count. So what I'm going to do is I'm going to use something called complementary counting. Complementary counting. Okay. And when I say complementary, I spell it here with an E intentionally because it's not a compliment like when you pay someone a compliment for doing a nice job on something, or you compliment their shoes or their hair or something like that. We're talking about a compliment, and this comes from the word complete, okay, which means something that completes the whole. All right, and in this case, there are squares that contain the mouse, and there are squares that do not contain the mouse. And between those two things, if you add those two things up, you will get the total number of squares in of any size in this diagram. Okay, so so in this case, I'm going to count the number of squares that do contain the mouse, and then if I subtract it from the total number of squares, then I can figure out how many do not contain the mouse, because there's only two options. A square can contain the mouse, or it doesn't contain the mouse. There's nothing in between. So those two options complete the whole. So first of all, let's look at the total. Let's look at the total squares in this diagram. Okay, now we're only talking about squares, not there's some other things here, like here's a rectangle. All right, and there's lots of rectangles in here, but they are asking only for squares. So we got to figure out how many squares there are of any size. Oops. So so let's do that. Let's just do some casework here. If I look at just the single squares, I know there's 16 of those. And then there are 2 by 2 squares. Okay. And so let's take a look at 2 by 2 squares. I'm going to pick up another pen. And you can see I could trace one here. Now I'm trying to find the total, so it doesn't matter whether or not they have mice in them. This one happens to have a mouse, and this one has a mouse. This one does not have a mouse, but I'm just going to go for the total first before I count the number with the mice. Alright, so I can see there's 3 across this row as I slide it along. And you can see there's, if we take the rows 2 at a time, there's 3 sets of 2 rows. Okay, so we get a total of 3 times 3, which is 9 squares in this 4 by 4 grid. So let's move on. Let's just do this systematically. Let's look at the 3 by 3 squares. Okay. Now, you can just kind of do it the same way. Let me actually pick up another color. I'll just use red again. Okay, so 3 by 3 squares. Now, You can see here's one 3 by 3 square, and if I slide it over I can get another one, and then I can slide these two down, so you can see I can get a total of 4 of the 3 by 3 squares. And it looks like they're actually all going to contain the mouse, right? But okay, we're not worried about that. And then finally we've done 1 by 1, 2 by 2, 3 by 3, and then we have, of course, the biggest one, the 4 by 4, the whole thing. I'll just sketch it here. And of course there's only one 4 by 4 square. Okay, so we have a total of, I'm seeing 1 and 9 and 4 and 16, so that's a total of 30 squares total. So now I'm going to count the number of squares that do contain the mouse. Alright, not the squares that don't contain the mouse, which is actually what we're looking for, but I'm just going to count the ones that do contain the mouse. So, okay, let's just go through it systematically again. Single squares, I'm going to write M's because I don't want to have to draw a mouse. So M means mouse. There's only one of the 1 by 1 squares that contains a mouse, right? And if we look at the 2 by 2 squares, you're going to get, you know, one here, oops, one here, one here, and one here, right? So you just sort of pivot around this mouse, and all the there's 4 squares that contain 4 2 by 2 squares that contain the mouse. Okay, so I'm just going to put M here, but that's just the first case. So M just rotates to the different corners for each of the different 2 by 2 squares. All right, so now let's look at the 3 by 3s. Okay, so we have 3 by 3 squares that contain the mouse. And again, you know, we've got, if you look at the ones that contain the mice, actually we said over here that they actually all contain the mouse, right? When I was going through that. But, you know, you can see that there's a 3 by 3, there's a 3 by 3, and then you just come down here. So they're really all going to contain the mouse. So there's 4 of them, they all contain the mouse. And then finally, we've got the big 4 by 4 square, the whole thing. There's only one of them. And that definitely contains the mouse. So how many total do we have that do contain the mouse? So we've got 8, 9, 10. We have a total of 10 that do contain the mouse. Okay. So if we're trying to count those that do not contain the mouse, we can take the total and subtract the ones that do contain the mouse, and then what's left over will be the total that do not contain the mouse. Alright, so all we need to do is take the total number of squares, subtract the 10 that do contain the mouse, and that means there are 20 squares that do not contain the mouse. Right? Good.